Today we're going to be doing the side and angle relationships of triangles. So when we're talking about sides and angles of a triangle, there's some relationships that happen. And side and angles of polygons having the same measure are called congruent. And if you remember the word congruent, it means same size, same shape. And I'm going to skip down here for a minute. We can write congruent with an equal sign with a wavy line on top. That's the mathematical symbol for congruent. So go ahead and skip down there and do that, please. So we're specifically going to be talking about isosceles and equilateral triangles today. And in an isosceles triangle, the angles opposite the two congruent sides are also congruent. So if you look down here at this triangle, these two are congruent sides. So this side is created by that angle, and this side is created by that angle. So that's what we mean by when we're saying the opposite. The angle is A, it creates the side BC. The angle is C, it creates the side AB. So we can go ahead and say that the side AB is congruent to the side BC. So angle A is congruent to angle C. Sometimes you'll also see a line above it. I can't do that on my computer, so you can also write it just plain, but if you see a line, a bar above it, that is what that means. It means the side. In an equilateral triangle, all three angles are congruent. And so if you remember, the sum of all angles, no matter what the triangle, will be 180. So if these are all congruent, each will measure 60 degrees, which I get by having 180 divided by 3. So if you look over here, we know that this side here, LM, from L to M, is congruent to side MN as well as LN. So since the sides are all congruent, so are the angles. Angle L is congruent to angle M as it is to angle N. And so it makes sense that no matter what the size of the equilateral, all the angles will be 60 degrees. So in this section, we're going to solve for the missing part. So in this first one, we have two of the three angles missing. And this hint is real important. The sum, if I add up all the interior angles, the sum is 180. So I can write this equation. I get 70 plus 40 plus x equals 180. The first thing I'm going to do is simplify like terms. 70 plus 40 is 110 plus x. I subtract 110 from each side because it is an equality. I have to do the same thing. These cancel each other's out. I've isolated the variable, and I am left with 70. Now, that was a long way to get to the point that this angle right here is making that side, and since it is a congruent side, this angle right here would be making that side. So since they're congruent, they would be the same measure. But we just did the math to prove it. All right, so look at this one. And let's remember that congruency when we do it. We know that this side is 7 inches. We know this side is congruent, so it also must be 7 inches. So with that, there's not a mathematical way to get the sides yet. So with that, we do have to recognize the congruency. Now over here is asking us to find both the x and the y. The y is talking about that angle, and the x is talking about that side. So because we've already talked about isosceles triangles and equilateral triangles, I know that all three sides are going to be the same because I see that congruency tick mark right there that lets me know that. So the missing side is also 3 meters. Well, so are the angles. If the sides are all the same measure, so are the angles. They are congruent also. So it is 60 degrees. All right, so those seem pretty easy. Now take a look at these. These are the ones you're more likely going to see. So the first thing we need to do is identify what type of triangle we have here. And this one is an isosceles, which means that I have two sides that are the same length and two angles that are the same length. So the first thing I want to do is I want to look at my sides. This side is congruent to this side. That means they are equal. So I can write the following expression. 3.2 is equal to 4y. Where did I get the 3.2 from? This side measure that they gave me, the 4y from this one. So now I have to work at isolating the variable. I have multiplication going on, so the opposite of that is division. And so I have isolated the variable, y it's by itself, because these two have canceled out. And so now I have a division problem where I have 4 into 3.2. And so I think you can see that y is equal to 0.8 or 8/10. So now I also have to solve for x. So when I solve for x, I have to look at what they give me. Well, for x, I have an angle measurement. I have 1/2 x. That's a pretty bad looking 2. There. 1/2 x is equal to 52. So when I look at that, I get those measurements from what they give me. So the opposite of 1/2 would be multiplying by 2 over 1, or we can think about it as just multiplying by 2. These cancel each other out, and I'm left with x by itself. 52 times 2 would be 104. So x is equal to 104. So they look really scary because they have rational numbers in them, but they're really not that bad, are they? So let's do the next one. All right, again, this is asking me to identify x and y, so I need to look at what type of triangle I have. I see a congruency mark, a congruency mark, and a congruency mark. I see 3 congruency marks, so that tells me I have an equilateral triangle. So when I have equilateral triangles, it means that all my sides are the same, and they all are the same measure. So I can set up this piece, 16.9 is equal to y minus 3. So then I have to just isolate my variable. To do that, I would add 3 to each side. And remember, when you're adding with decimals, you do need to keep them in alignment. So I do like to go ahead and add that 0.0. It just helps me keep it in alignment. And I am left with y equals 19.9. Okay, so now I need to do the angles. And so that part we mentioned about each angle being 60 degrees, that's where that comes in here. So no matter what the side lengths are, in an equilateral triangle, the angles will always be 60 degrees. So I would have 3x equals 60. To isolate that variable, I would need to divide by 3, and I get x is equal to 20. And there I've solved from x and y. And those really aren't as hard as they look, but they do look a little intimidating with the parentheses and the variables and the degree signs. Ay, ay, ay. Just slow it down, do it on a bigger sheet of paper if you need to, and do your best.